Good evening, everyone. I'm Dr. Pratyush. I'm a hematopathologist based in Kolkata, and today I'll be taking you all across through the diagnosis of acute leukemia by flow cytometry. So we're going to discuss how we can diagnose a case of acute leukemia on flow cytometry with various approaches and various antibody markers. So WHO 2022 fifth edition has put forward a lot of changes now, where we can see B lymphoblastic leukemias and AMLs showing a lot of new changes and a lot of new mutations being added. Where we have BCR-ABL like fusion, BCR-ABL fusion, we have ETV61X1 like fusion, and so on. And in AML, we have major changes like we have KMT2 in 2A, MECOM, and NUP98 rearrangement, which has been added in the defining genetic abnormalities. Other than that, we have PML-RARA, RUNX1, RUNX1, T1 fusion, and other DEC NUP214 fusion, RBM15, MRTFA fusion, and so on. So these are the defining genetic abnormalities, and the AML that is defined by differentiation. So basically, the fifth WHO has classified AML into these two broad entities where we have defining genetic abnormalities and AML defined by differentiation. So one of the major changes again goes forward in WHO 2022, where we say that we do not need a blast cutoff to call it an AML, or we do not need 20% blasts to call it an AML when we have certain recurrent genetic abnormalities present in the patient. Apart from all the translocations and mutations, we have an exception of BCR-ABL1 and SEPA mutations, where we need 20% blast to call it AML. In contrary, where we see the ICC 2022 classification, there we have to say that at least 10% blasts have to be there to be called as AML, except for BCR-ABL1 fusion. And some major changes have also been done to the AML MRC, which was multi-lineage dysplasia related changes that was there in 2017. And now in 2022, we have divided AML MRC and we have labeled it as AML MR. And we have divided them into two types, that is defining cytogenetic abnormalities and defining somatic mutations. So in somatic mutations, we have all these mutations, and in defining cytogenetic abnormalities, we have all these defining cytogenetic abnormalities. So, can anyone tell me what are the various cytogenetic defining abnormalities that are seen in MDS that has been recently added in WHO 2022? Please write your answers in the chat box for the discussion. That is, tell me the cytogenetic abnormalities that are seen in which are defining cytogenetic abnormalities in MDS. So, what is the broad classification that how we can classify the acute leukemia? So, basically, broadly, we can classify them as acute lymphoblastic leukemia. We can classify them as AML, that is acute myeloid leukemia, or we can call it as MPAL, that is mixed phenotypic leukemia. So, acute lymphoblastic leukemias can be divided into B and T ALLs. AMLs can further be classified on the basis of their cytogenetics and morphological abnormalities. And MPAL can be B myeloid MPAL, it can be T myeloid MPAL, it can be T monocytic, and so on. So we'll discuss all these cases one by one. So when we have to call a case as acute leukemia, we have to divide the acute leukemia into three different types that we already discussed. That is acute lymphoblastic leukemia, acute myeloid leukemia, and mixed phenotypic leukemia. So when we are calling a case as acute lymphoblastic leukemia, then we have to classify them as B lineage or T lineage. So when we are saying B lineage, we have to see the presence of CD19, CD20, CD10, 22, 79 alpha, TDT, and when we are calling it as T, we have to look for 2, CD2, CD3, CD4, CD8, 5, 7, TDT, and 1A. So on the basis of these markers, we can classify the acute leukemias, acute ALL into BLL or TALL. And further, when we have to classify the AML, we have to look for myeloid markers, that is the presence of cytoplasmic MPO. We have to look for CD13, CD33, CD117, and CD15. So usually, the AMLs can be classified on the basis of CD34 and CD117. So the AMLs can be either 34 positive and 117 negative. It can be both 34 and 117 positive. It can be both 34 117 negative, or it can be just 117 positive and 34 negative. But that doesn't mean if the AML is 34 and 117 negative, it does not mean it is not AML. We have to look for cytoplasmic NPO and CD1333 for further classifying these cases as AML. So when we have to call it as AML with monocytic differentiation, we have to see the presence of monocytic markers. So there are various monocytic markers like CD64, CD14, CD36, there is CD11B, 11C, and so on. Lots of monocytic markers are there. HLA-DR is there. So when we have to call it as AML AML with monocytic differentiation, we have to see the presence of at least two monocytic markers, and then we can call it as AML with monocytic differentiation. And when we are seeing AML with erythroid differentiation, we always see a blast in CD45 negative site scatter window, which is showing expression of CD71 and CD235A. So these are the markers which must be present to call it as acute erythroid leukemia. And when do we call it as acute megakaryocytic leukemia? When we see a blast population again in CD45 negative window with a low site scatter and showing positivity for CD41 and CD61, and sometimes aberrant expression of CD36, we can always think of a acute megakaryocytic leukemia. Moving on to the mixed phenotypic leukemias. So when do we say that it is a mixed phenotypic leukemia or it is a MPAL? We call it as MPAL when we see that the same blast is showing expression of more than two lineages. So more than two lineages, what do I mean by more than two lineages? So it can show expression of B along with myeloid expression, or it can show T along with myeloid expression, or it can show myeloid expression with T lineage, and so on. So it can, for not all the markers can be present together. So we have to see lineage defining markers. So lineage, what do I mean by lineage defining markers? So we have to look for MPO if we have to say that it is of myeloid lineage. So in case of a BALL, suppose we have a case of BALL and it is showing aberrant expression of CD13 and 33. Do we go ahead and call it as MPAL, as B myeloid MPAL? No, we do not call it as B myeloid MPAL until and unless we do not have the expression of cytoplasmic MPO in the same blast. So we have to see that the B lineage cells are showing expression of MPO to call it as B myeloid MPAL. So similarly, when do we have to call it as we can assign the lineage as monocytic when we are seeing at least two strong expression markers of monocytic lineage like CD14, CD64, CD11C, CD36, or lysozyme. Similarly, when do we assign a lineage as B lineage? When we either see a strong expression of CD19 with either CD10 or cytoplasmic 22 or cytoplasmic 79 alpha. So if there is 19 weak expression in a case of AML, in a case of acute leuke where we are seeing myeloid blasts showing expression of CD19, do we call them dim CD19? Do we call them a mixed phenotypic leukemia? No, we do not call them mixed phenotypic leukemia when we are seeing myeloid blast expression dim CD19 because CD19 was weak. So always AMLs with CD19 dim expression can be thought of core binding factor leukemias where we see aberrant expression of 19, 79 and CD56 and so on. So we need to have either a strong expression of CD19 along with 10, 22 or 79 alpha, or when we are seeing a weak expression of CD19, we have to have at least two more markers to call it as B lineage, that is 10 or 79 alpha with 22, or we have to see 22 with 79 alpha, or either ways. Then when do we have to call them as a T lineage? How do we assign a lineage T? So T can be said when there is strong cytoplasmic CD3 expression or there is strong surface CD3 expression. So this is how we assign the various lineages in a case of acute leukemia. So this is the panel that we use at my center. We have a acute leukemia screening tube where we have tagged various antibodies with various fluorochromes so that we can see the expression of the CD markers. Similarly, when we screen the acute leukes first and we see that the blasts are showing a proper lineage assignment, a lineage assignment is done, and then we do the further panels for the acute loop. That is, we run a BALA diagnostic panel or we run a AML diagnostic panel to do a further exact phenotyping of the acute loop. So why do we use a panel? Why do we design a panel? We design a panel in such a way that we can think of various diagnoses at the point of screening in a single tube. So in one tube, we are going to add cytoplasmic MPO. We're going to add, which is a myeloid marker. We're going to add a CD79 alpha, which is a B marker. We're going to add a CD34, which is a immaturity marker. We're going to add a cytoplasmic CD3, which is a T marker. Then we are going to add a TDT, which is a immaturity B or T marker. Then we have a CD45, which is the common lymphocytic marker. Then we have FX cycle. What is FX cycle? Can anyone write in the chat box? What is the meaning of FX cycle and what is the function of FX cycle? Then we have CD7. The CD7 is used to assign a T lineage. Then we have CD19, which is the most important B lineage marker, and there is CD117, which is immaturity marker. So using these, we can diagnose a case of or screen a case of acute leukemia. How? So MPO will be positive in myeloid blast, 19 and 79 alpha will be positive in B blast, cytoplasmic CD3 and 7 will be positive in T blast, along with and we call them blast when we have a immaturity marker associated with them. It can be 34 positive, it can be TDT positive, it can be 117 positive. And further, we do a B diagnostic LAIP or MRD panel because we have to further treat the patient with various immunotherapies or chemotherapies. And after the chemotherapy is done, we have to monitor the MRD. So what is MRD? MRD is minimal residual disease of acute leukemia. So when we have MRD, we have to look for LAIP markers, that is the leukemia associated immunophenotyping markers. So we'll be discussing more about the MRDs. We are going to discuss more about LAIPs in further lectures, and we're going to discuss more how these antibodies can be used to diagnose MRD in next lectures. Similarly, we use AML diagnostic and MRD panel for further classifying the AML with various antibody panels. So this is all about the theory that we had to know to diagnose a case of acute leukemia. So now we'll be going on further and we'll be discussing various cases. I want active interaction. Please, all of you who are willing to answer, please put forward your answers in the chat box and we can discuss the answers as well. So first case. So first case, we can see CD45 side scatter here. And on CD45 side scatter, we are seeing a major population here, which is CD45 negative to dim, and it is gated and colored into a color red. And this CD45 negative to dim population is showing heterogeneous expression of CD34. So what do you mean by heterogeneous expression? Means it has a long log variable and it is showing expression of CD34. How do we say that CD34 is positive over here? Because we have gated the granulocytes with a blue color, that is a population 4. We have put the P4 population here. So this P4 population, meaning the granulocytes or the neutrophils, these neutrophils will not show CD34. This is used as a negative control. So anything, any cell that is showing an expression beyond the neutrophils will be CD34 positive. So I mean to say that the neutrophils will never show 34 because 34 is an immaturity marker, and neutrophils will never show 34, and anything beyond the neutrophils will be 34 positive. So we are seeing the red cell being 34 positive 117 negative, as we are seeing no cell is there which is showing a CD117 cluster. So these scattered events are not taken into account. Then we are seeing these red cells which are 34 positive showing co-expression of 19 and CD10. So we are seeing there is a single cluster being formed which is showing expression of 19 and CD10. So these cells further on CD13 and 7 plot are showing negativity for CD13 and CD7. So here in this plot, we have looked after the immaturity markers, we have looked for B markers, we have looked for myeloid and T marker. So T markers have been ruled out because 7 is negative and CD13 is negative. So myeloid marker is also taken out. Then 19 and 10 is positive, co-expressing, and 34 is positive. Moving on to the next plot of the same case. So on this, the same red population has to be studied. We are seeing that there is some CD20 positive B cells over here, which has shown some expression of CD20, and we are seeing the red population showing a heterogeneous expression. So again, the cells which are red colored are moving towards CD20. So this is CD20 negative to dim expression. So this is heterogeneous expression of CD20. Along with that, we have positivity for HLA-DR. We can see a clear cluster being formed with HLA-DR positive cells, and these are CD5 negative. These are CD22 positive. These are TDT positive, which is immaturity marker again. This is 79 alpha and TDT co-expressing, meaning that these are B precursors possibly. And in the previous plot, we had seen that those red cells were showing 1910 co-expression, and those were also 34 positive. And here we can see that these are MPO and cyto CD3 negative on this plot. So we are seeing that all of these red cells are showing expression of possibly precursor B lineage markers. So together we can form a diagnosis of B cell precursor acute lymphoblastic leukemia.